Hello, this is our presentation, and we are going to be doing analysis on Schuler's location when he's at Cleveland Commons and the SeaTac Airport. So what we do first is download this pickle file, which has his location data with a date time index and a latitude longitude point. We drop NAs so that every point has values in it that are not NaN. Um, and this is when we start the analysis on the Cleveland Commons data. This is the location of Cleveland Commons right here, this point. And we use the great circle function to see how many points in this data frame are within 30 meters of Cleveland Commons. So those are in these two code cells. Um, and you can see that data here. And it's mostly at the north end, which likely signifies that he usually goes to cafe and not grill. He's probably a coffee guy. Um, and yeah, so there's 280 days where he goes to Cleveland Commons, but not necessarily, because this would double count when he is in Cleveland Commons twice within like 2 minutes or 10 minutes. So we have to remove points where he's been there more than once in a day. So we go here to resample by day, and the number drops from 280 times to 42, which is much more reasonable. And so we can plot this data, and as you can see, it's a lot more sparse. So resampling definitely helped to visualize this.
Okay, so with our pickle file and data frame already uploaded, we want to answer another question, which is how many days has Schuler been to SeaTac, the airport in SeaTac? And so first we get rid of the column from the previous analysis, and we get the distance between every single point in the data frame and this distance to SeaTac using the great circle. So that's right here. These are all of our points and their corresponding distance from the airport. Now then we filter the data frame to only include points that are within 1,000 meters of our SeaTac, which latitude and longitude, which we found on Google Maps. And so here we are. These are all these points. And now this suffers from the same problem as our Cleveland analysis, where as these data points are recorded once every 1 to 10 minutes, there's a lot of double counting. Presumably, Schuler did not enter and exit the airport within 1 to 10 minutes. There's going to be a lot of double points, for example, waiting in security or waiting in line. So we resample per day, and we get the mean. So we just take the mean of every point that we have determined that is within 1,000 meters per day. So this will just be his mean location in the airport on that day. And we can see that it cuts down the data frame a lot. As we see, here's the visualization of that. We can see it cuts down on the amount of points. Zooming out, there's a few points on the runway, but most of them are clustered where we would expect people spend the most time in the airport, like in the terminal. And so then we we found the length of this data set, which is 73. So he has been to SeaTac on 73 days. However, we noticed that a decent amount of them were consecutive days, which is likely him staying at a hotel either before or after a flight. So we wanted to only see the amount of days he has either flown in or out of. Uh, so we resampled to every 2 days and then dropped in A and found the length of that, which is 67. So we can conclude that on 67 days, he has only been at SeaTac for 1 day, meaning likely he flew in or out on the same day as arriving or leaving. And on 6 days, he stayed at an airport in the hotel on a day adjacent to the day he flew in or out.
So this is our above and beyond. And in our above and beyond, we will find Schuler's average location in the data frame that we've been working with, which is df daily c underscore 2, which is the data frame that's resampled for every 2 days. So it doesn't include consecutive days where he would spend the night at the airport or in a hotel close by. So we graph this mean and plot the entire data frame against the mean to see if we can draw any conclusions, and we can. The mean is right here, which is located between the N, C, and D gates, which indicates that he spends time individually at each of these gates. So it would make sense that his average location is kind of between these. So yeah, thank you for watching our presentation.